Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Logarithmic Formula Memorization Basics. Concept number 6, Product Rule of Logarithms, the log base b of x times y. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is super effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a brand new paradigm. I want to include everyone who needs a boost in Algebra 2, and if I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com for your healthy dose of Algebra 2 by ordering and purchasing the complete Algebra 2 cram session beyond the logarithmic formula memorization basics. You have lots of peers, classmates, colleagues, and or friends who are taking Algebra 2 as well, and they could benefit from this cram session, so be sure to spread the word and tell them to inbox me at memedicine@gmail.com so that they too can order and purchase the complete cram session. You'll be glad you shared the information because they'll make great study buddies. Let's delve into the concept. Logarithmic formula, product rule. Solve log base b of x times y. Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you are able to press pause and come up with a formula, but if not, that's completely fine. And before mentioning the general formula for the log base b of x times y, we first need to understand the general format for an exponential function because exponential functions are the basics for all logarithmic formulas, okay? The general format for an exponential function is going to be y is equivalent to base b raised to the x, where base b is positive. That means it's never going to be, it shouldn't be negative, at least not for this concept, and it's not going to be equivalent to 1. Okay, so any function of this format is called an exponential function, and here goes a graphic representation of an exponential function on a coordinate plane, okay? And don't get this format confused with a polynomial function where the base is actually the independent variable x and the exponent is a constant. Because here in the format for the exponential function, we're going to have our base as the constant. The exponent is the independent or input variable x, the variable that runs along the horizontal axis on a coordinate plane. And then the dependent or output variable is called the power, y. And sometimes these two labels are interchanged, but that's actually a misnomer. An exponent is what you're raising the base to, what you're, the amount of times you're multiplying the base by itself, and the power is the result. For example, if the value of the exponent were 2, then you would say that y is the second power of base b, which corresponds to an exponent of 2, okay? All right, so a logarithmic function is the inverse of the corresponding exponential function with the same base. So let's show, let's demonstrate how you would format the logarithmic inverse of this particular exponential function, okay? So you're going to have y is equivalent to the log base b of x. And in this format, it's kind of difficult to understand what's going on if this is your first time seeing something like this. But what the logarithm function is trying to establish is what exponent, which in this case will not be y, do you need to raise the base b to get the power of x? And since I told you previously that it's the inverse of the exponential function with the same base, let's re-express this in exponential terms, okay? So what you basically do is interchange the dependent and independent variable, and you get that x is equivalent to base b raised to the y, okay? And remember that algebraically, in order to yield the inverse function of your starting function, all you basically have to do again is switch the dependent and independent variables, okay? Or simply put, you switch the x and y values. So for this or any inverse functions, constants are always going to remain the same. So the constant in the exponential function is going to be a constant in the inverse or logarithmic equivalent. Okay, but now x is going to be the power or the result, and y becomes your exponent in the inverse logarithmic function. These two functions are one and the same. Even if you're a little confused, they're basically saying the same thing, okay? And on a coordinate plane, the graph of the logarithmic function is the reflection of the corresponding exponential function graph over the line y equals x. Okay? All right, so here you go. Now, in the case of the log base b of x times y, the log of a product, the product being x times y, is equal to the sum of the log. Okay, how do I say this? It's equal to the sum of the log of its factors, but it's better shown than said. So the log base b of the product x times y is going to be equal to the sum of the log of its factors. The factors of this product being x times y, or we can say that the multiplicand is x and the multiplier is y, however you like expressing a multiplication, I don't know, expression. Okay, that's kind of doubling up on words. All right, so hopefully you're getting the gist of things. And I know you're probably thinking, okay, so if this is the case, prove it. Sometimes you just don't want to take things at face value. So we can justify our result on the right-hand side of this formula, okay? Okay, so we're going to sort this out by splitting up the product into its two factors. And as previously indicated, the log base b of x is an equivalent expression for x equals b raised to the y. Okay, if we were to express this in exponential terms as we established up here. Okay, and so yeah, this is basically converting this to exponential notation. And what we can also do is re-express this as m equals the log base b of x. So we're temporarily assigning the label m to this mini expression that we extracted from our formula over here, okay? And again, if we convert this expression to exponential notation, we can again re-express this as x okay, here this becomes our power, is equivalent to the base b, our constant, raised to the m, the label or the value that we assign this, or what's now going to become our exponent or dependent variable. So m and y kind of hold the same place here, okay? That's why I'm aligning this here to show you what's going on. All right, so what we're doing now is an algebraic manipulation in order to prove that the log base b of x times y is equivalent to the log base b of x plus the log base b of y, okay? And likewise, the log base b of y can be re-expressed as n is equivalent to the log base b of y. We're just using n as a label for this particular expression, or you can even look at this as the dependent variable, okay? Or again, if you were to re-express this using exponential notation, this would then become y, which is our power, equals our base b, our constant, raised to our exponent of n, okay? All right, so we're just gonna, keep these to the side for a second. And remember, we're just trying to prove that this entire expression or formula is true, okay? All right, so using exponential formatting, the product x times y can then be transformed into the following. And we're just going to stick to our exponential notation formatting, okay? So it makes sense that where just the product, x times y, is equivalent to b raised to the m times b raised to the n, because here we're told x equals b raised to the m. Okay, ignore this. This was just to show you how this can be transformed into exponential notation. And we're also told that y equals b raised to the n, all right? Okay, and now I don't know if you recall, if you're even aware, there's a multiplication property of exponents, and we know that when we multiply two bases, the same base, but they have different exponents, what we can do is combine the base and add the exponent. So what we get is b raised to the m plus n. Again, because we have the same base, all we have to do to simplify this expression is add the exponents, okay? Now let's try to reconstitute the beginning concept where we took the logarithm of the product. So the log base b of x times y is going to be equivalent to the log base b of b raised to the n plus n, because it's equivalent to x times y, our product. So these two expressions on the left-hand side and the right-hand side are essentially the same, okay? I hope you're not mentally exhausted and you're following my drift. And before moving on, I want to take a little detour, and I want to introduce you to the cancellation property of exponents that says if we take the log of a base b and that the base, what we're evaluating is the base raised to some particular exponents, and then these two bases are basically going to cancel. They cancel each other out, okay? And what we're going to be left with is just the exponent, because remember that I told you previously, the logarithm function just establishes what exponent you're raising the base to, okay? And this makes sense if you really think about it, because we're basically trying to determine what exponent you're raising the base to in order to yield this result or power. Well, here in this particular format, you're told the answer without having to figure anything out. You're told that the exponent is x, okay? So getting back on track using the same cancellation property of exponents, we know that this is basically going to be equivalent to m plus n because we're canceling out the bases, okay? We essentially are being told the answer that the exponent that you have to raise base b to is going to be m plus n. All right? Okay, let's move right along. And now we can go back and undo our labeling because we know the values for m and n. And when we do that, we get that the log base b of x times y is equivalent to m plus n, or m, which is equivalent to log base b of x, plus the n, which is equivalent to the log base b of y. So essentially, here goes our proof, okay? And we just prove why the log base b of x times y is equivalent to the log base b of x plus the log base b of y. I know this was a little circuitous, especially if you're not well rehearsed in doing proofs, but if you look at it a few times, it will all make sense, I promise you, okay? And, just stay tuned and order more sessions so you can get comfortable with this type of algebraic manipulation. Thanks for tuning in. And if you want to know what's the point of all this, knowing how to interconvert logarithmic formulas is relevant because they're used to simplify and manipulate equations when you're figuring out some type of algebraic solution in a bigger scheme, in a bigger problem, okay? And as you can see, intellectual comprehension of this material was not difficult. And after the short amount of time it takes to complete the entire Cram session, you'll be prepared to answer a battery of questions about any Algebra 2 concept. So inbox me at memedicine@gmail.com to order the complete Cram session. Thanks for tuning in and good luck studying.